Hi, this is Barnaby. This is our video about calculating products.
And hi that you heard first was Saya.
And I call it calculating products because that makes more sense, because you want to know how much stuff you're going to make, but really it doesn't have to be products. Really it could be anything in the whole chemical equation. So it could be how much of a different reactant do you have to use, or how much for any product you're going to make. So we're going to work with the problem in your lab that you already saw the work for, and you have a sample problem on your lab. So we have a balanced chemical equation. This one relates the amounts of the chemicals to each other. So one of these makes one of these and 5 of these. Or if you make 5 of these, then you also make one of these. Or if you make 5 of these, then you use one of these. And then here's the work for the problem from the sample calculation. So let's just go through this again. And then on next class day, we'll also be going through that work again and doing other practices. And these problems are kind of long, but all the steps are always the same. So once you practice, it's not too hard. So the steps to these are first mass. Do you know what mass is?
What?
How much something weighs.
Oh.
So that's usually grams. And next you convert to moles. Do you know what moles are? He said he doesn't know. And a mole is just a certain number of atoms, like a dozen. Do you know how many a dozen is?
12.
12. And we're converting to moles because this equation is all about counting. It says 1 and 1 and 5. So we can't do mass because atoms weigh different amounts. We have to do something you can count.
Dozen. Also, you can say 12 dozen too.
You could. 12 dozen would be a lot. And then the reason we convert to moles is so we can relate the numbers from the chemical equation. That's called a mole ratio. And that converts to the chemical you're trying to find in the problem. And then finally convert back to mass so you know how much it'll weigh. So in this problem, we're going to start with the mass. So that's what we've highlighted in blue here. What color would you call that?
What?
What color would you call that?
What?
This blue color?
Skylight blue.
Skylight blue?
Yeah.
Nice. There's a bird in our window hopping up and down. That's pretty funny.
Yeah, that sound was the dirty hopping up and down on our window.
Okay, so you start with the mass that's given to you in the problem. And notice I'm writing down the units also and the chemical also, because halfway through the problem we're going to change the chemical to find the water. And then before I even think about what I'm doing next, I'm going to take care of the units. That helps me not to have to memorize how to do this problem. So whatever unit you start with in the first step always has to go on the bottom of the next step to cancel out completely. So that unit has to go right down here, exactly the same, grams of CuSO4 parentheses HO in parentheses 5. And then the number that always goes with grams, because grams are the molar masses on the periodic table, and molar masses are below each element. So we're adding up 1 copper and 1 sulfur and 4 oxygens and 5 waters all together. Add them all together. Not multiplying, just add them all together. Okay, and then the next step in mole ratio mass is moles. So moles go on the top, and the chemical does not change. Whatever chemical is here is also here. Chemical does not change. And then the number that goes with moles when you're using the molar mass is always 1. Oh, I hear another baby. Just a second. Okay, we're back. So Ruby's here in 2 now.
And anyway, we had to pause the video because we was fine because we did it come right when we needed her. And Mommy is up there helping her come down towards with Timmy upstairs was my new baby.
Okay, so then before we even do the next step, whatever unit is in this step here, always goes on the bottom of the next fraction to cancel out. So that whole unit, exactly the same. Okay, and then the next step is mole ratio. Steps are mass, mole ratio, mass, so we're on the mole ratio step. So this whole thing is the mole ratio. These numbers that go in the mole ratio are not always 1, you have to find them. So you match up the chemicals. This one is USO4H2O5, so you find that one. That's one of those, and you find the water. That's 5 of those. That's why the numbers are 5 and 1.
Dina wanted apple.
Now we're talking about applesauce. And now...
No, we were not talking about applesauce. We were actually talking about apple soap.
Oh, apple soap, okay. So now, whatever unit is on the top here has to go on the bottom of the next fraction to cancel out. Exactly like it is. And then the last step is mass. So we'll be using molar mass. So once again, the number with mole is always 1 when we're using molar mass. And the grams are on the top because this is the mass step, and we find the grams on the periodic table. So the steps always go like that: mass, mole ratio, mass. If you let the units help you, you can see how they cancel out, and that can guide what goes on the bottom of the next fraction. Then if you just memorize mass, mole ratio, mass, then you'll know what goes on the top of each fraction. And then the number that goes with grams is always on the periodic table. The number that goes on the other side of that fraction is always 1. The numbers that are in the mole ratio come from the balanced chemical equation, and that's all there is to it. To calculate this, everything on the top press multiply, everything on the bottom press divide on a calculator. So this would be 1 times 1 times 5 times 18.02, divide 249.72, divide 1, divide 1, and the answer is 0.36 grams H2O.